Hi, today we are going to be solving logarithmic equations. But before we do, let's go ahead and introduce our property of logarithmic equations. So the property of logarithmic equation reads, I know you can read it, but I know you also miss my handwriting. So the property of logarithmic equation reads, if log base b of x equals log base b of y, then what has to hold true, or how would we solve it? What I want to point out is, what is it that looks exactly the same? So in this case, the base of the logarithms are the same. And if the bases are equal, and this is an equation, then if the bases are equal, then there's no way around it. The arguments have to be equal. So we have something to illustrate it, which I know you can read, but I'd rather work it with you. Elsa, there is no need for me to do these videos. You can just read your book and that's it, okay? So let's just say we were asked to solve this equation. So I'm going to ask myself, what kind of equation is this? You know, the same speech. Is it linear, quadratic, rational, radical, and so forth? So there's a log in there, so I guess we have a logarithmic equation. So we can either do fun math or keep our cool and apply the property of logarithmic equations. So I want to ask myself, what is it that is the same? As you can see, the base of the logarithm are the same, or the bases are the same. And the property of logarithmic equation states that if the bases are equal, then there's no way around it. Then the arguments have to be equal. So this was a nice problem in the sense that just by us setting equal the arguments equal to each other, we're done. But we're going to do some funner problems. Now, when it comes to solving logarithmic equations, the question that you need to ask yourself is this: how many logs do I have? Do I have just one log, or do I have more than one log? If you only have one log, then what you need to do is go ahead and write it in exponential form. But if you have more than one log, then you need to make sure that you have no more than one log on each side of the equal sign, kind of like in problem B. Okay, so let's go ahead and do fun problem number 1. We are asked to solve this equation. So let me go ahead and write it. So we have log base 9 of 5x minus 3 equals 2. And before we answer it, I want to remind you guys about things about logarithms that need to hold true. So we have log base b of x equals y, because I just wanted to write it like that. And there are things that we need to have in the back of our mind. One, we have to make sure that the base is positive, any positive number with the exception of 1. And also the argument also has to be a positive number. So these are just things that we need to make sure that hold true. Okay, so with that being said, back to problem A. It would be nice if I put letter A. So it's like, oh, okay, I got an equation with the log. So I'm going to ask myself, how am I going to handle it? So again, the question to ask ourselves when we solve logarithmic equation is how many logs do we have? One or more than one? So lucky for us, since we only have one log, then our primary goal is to quickly write it into exponential form. And then we can remember this, you know, log base b of x equals y. I don't memorize this because it's hard for me to digest. I just copied it from a book. So I like to remember it in words. So then in words, how do I go from logarithmic form to exponential form? To do that, we're going to take the base, raise it to some power, or exponent, pick your favorite word, and that should give you the argument. Okay, base to some power equals argument. So let me just go ahead, put that in our thinking area. Okay, so then I'm like, okay, what is the base? Well, we're going to take the base of the logarithm, which is 9. What is the power? So something that we need to bear in mind is, what does a log mean? A logarithm is just code for the exponent. A log is an exponent to which the base has to be raised to in order to get to the argument. That's too many words, so pretend I didn't say that. A log is just an exponent. So if you have that, a log is just an exponent, you're going to be cool. All right, so base to some power. Oh, what is the power? Oh, instructor just said that a log is just an exponent. If the log equals 2, then the exponent is 2. So base to some power will give us the argument. An argument is just code for what are you taking the logarithm of. For me, when it comes to solving logarithmic equations, the toughest part is just getting it out of the logarithmic form, out of the log form. So let's go ahead, just keep our cool and finish solving this linear equation. So the square of 81 is, the square of 9 is 81, and that will give us 5x less 3. You keep your cool, and then we add 3 to both sides. Give me a second, I'm running out of space. We add 3 to both sides, and that will give us 84 is equal to 5x. For the grand finale, to get rid of the times 5, let's go ahead, divide both sides by 5. Cool. So now I am very confident in our answer. I don't think I made a mistake, else you would have told me. But the thing is, when it comes to solving logarithmic equations, we need to make sure that our argument is positive. So I'm going to do what I call the argument check. Okay, and I'll explain what I mean in a bit. So argument check. The reason why I call it argument check versus actual checking is because if I was actually checking it, we will substitute our answer into our equation and then make sure we get a true statement. But I don't have time for that, so I just want to know, is my answer reasonable? And what I want to point out is our argument positive? So the argument, let me go ahead, highlight that. The argument is 5x minus 3. And our solution, or our proposed solution, is 84 over 5. When we plug it in, I just want to make sure that the argument is not going to be negative. So we have 5 times 84 over 5 less 3. Quotient of 5 in itself is 1, and that will leave us with 84 minus 3, which gives us 81. I believe that's a positive number. So in this case, our solution passes the argument check with colors. Cool. Now, does this mean that our answer is right? No, that just means that it's acceptable. It's not going to be an extraneous solution. But for those of you that are overachievers, they're like, no, I don't want to do the argument check. I need to actually check it. Then let me just put check. I should put real checking, but I don't feel like doing that. So if I was really checking it, we will write the equation. We have log base 9 of 5x minus 3 equals 2. And then our proposed solution, I'm always going to call it proposed solution until we check it. So again, for me, I just do the argument check because I want to make sure that my argument is positive. But for those of you that are overachievers, they're like, no, I must have confirmation that our answer is just correct, not just acceptable. Okay, so let's plug it in. So we have log base 9 of 5 times our proposed solution, which is 84 over 5 minus 3. And for my peace of mind, this needs to equals 2, else we're coming to situation. Once again, quotient of 5 in itself is 84. Difference of 84 and 3 is 81. And then the question of the hour, does the left side equal 2? Well, this 2 is in my way, so I'm going to cover it up. Pretend you can read that as a 9. So log base 9 of 81 equals what? So what I have to ask myself, base to what power is going to give us argument of 81? Last time I checked, 9 to the second power equals 81. So log base 9 of 81 simplifies to 2. So left side is 2, right side is 2. Now that we actually checked it, because we're overachievers, we know that our answer is correct. Cool. So that's one problem down, one more to go. Problem B, I really like problem B because it spices it up a little bit. We have more than one log term. Alright, and so to wrap up this short video, let's go ahead continue with problem B. So again, once again, we have a logarithmic equation. So what I'm going to ask myself is this: how many logs do I have? Do I have one log or more than one log? And unfortunately, unlike problem A, we do have more than one log. So when we have more than one log, we need to make sure that we have no more than one log on each side of the equation. So I'm cool on the right side. My issue is with the left side. We have more than one log. So we are going to use the properties of logarithms to backtrack it to a single logarithm. So I'm like, silly logarithm rules, they make me so mad. So remember, we're just going to pretend like we have bad English. Silly logarithm rules, they make me so mad. So I'm going to ask myself, what is going with the logs? Am I adding them or am I subtracting them? In this case, we are adding them. So if we are adding them in order to backtrack to a single log, we have to multiply the arguments. So that will give us logarithm base 8, and we multiply the arguments, which is 2x plus 5 times 3. We're going to go ahead and wrap this together just to highlight that the entire product is the argument, equals log base 8 of 33. And at this point, the question is, how are we gonna handle it? We can do some fun math, but we don't have time for that. We're just gonna keep our cool and use the property of logarithmic equations. So the property of logarithmic equation states if the bases are equal, then there's no way around it. Then the arguments have to be equal. So the left argument has to equal the right argument. So we have no logs, so let's go ahead and clear those grouping symbols. Product of 3 and 2x will give us 6x. Product of 3 and 5 will give us 15, and that should give us 33. Take your time, punch it in or freehand it. To isolate the variable term, we'll subtract 15 from both sides, and 33 minus 15, who has a calculator? Sorry guys, as you can see, I needed to put a little band-aid because I'm not good at arithmetic. Alright, so we have 33 minus 15 after I use my fingers gives us 18, and that equals 6x. Alright, to finish it off, to get rid of the times 6, let's go ahead and divide both sides by 6, and that will give us x equals 3. Under normal circumstances, I will box it and move on because I know that you guys are awesome, and if I make a mistake, you guys are really good to tell me, kind of like the mistake that I did right here. But when it comes to logarithmic equations, bear in mind we need to make sure that we need to make sure that our solution doesn't make any of the arguments negative. So when you do the argument check, you don't really have to write it out like we did in problem A. You can just do it mentally. Like 3 is a solution, so we have 2 times 3 is 6. 6 plus 5 is 11. Last time I checked, it's positive. Cool. The next argument doesn't have a variable. The next argument doesn't have a variable, so it passes the argument check. We're good. Now if you really wanted to check it, so remember the argument check, I just want to know, does my answer fly? In this case it does, because our answer doesn't make any of the arguments negative. But if you really wanted to check it, you will punch it in and then make sure that the left side equals the right side. In this case, I guess make sure that the left side gives you log base 8 of 33. Alright guys, that's my time until we do the next video. Thank you.